July 13, 1944, near Saint-Lô, Normandy. The Allied advance in France has slowed to a crawl. For 6 weeks, American tank units have struggled to move beyond the beaches. More than 400 Sherman tanks have been destroyed in this small corner of France, many catching fire before their crews could escape. Each attempt to push forward ends the same way, burning steel and dead men. The enemy is not just German firepower. It is the land itself. The ancient Norman hedgerows, thick earth banks, 4 feet wide and 12 feet high, reinforced by centuries of roots and stone, form natural fortresses across the countryside. Whenever American tanks try to climb them, their thin 1-inch belly armor is exposed. German Panzerfaust teams wait for that moment. A single shot under the hull is enough to kill a tank and everyone in it. At this field stands Sergeant Curtis Cullen, age 29, of the 102nd Cavalry Reconnaissance Squadron, 2nd Armored Division. For the past 2 weeks, he has worked on a solution built from captured German steel. Pieces of Czech hedgehogs, beach obstacles originally placed to destroy Allied landing craft. American engineers cut them apart and piled the metal nearby. Cullen saw something others didn't: potential. Today, a Sherman tank, fitted with Cullen's improvised steel prongs, a rough, 4-toothed device welded to the bow, will attempt to break through a hedgerow, not climb it. If it fails, the idea dies here. If it succeeds, the stalled First Army may finally have a way out of the bocage. General Omar Bradley has arrived to witness the test himself. No approval had been given before. No guarantee of adoption exists now. But the stakes are clear. 3,000 tanks depend on a breakthrough. So do the men who drive them. Lieutenant Charles Green of the 747th Tank Battalion commands the test vehicle. His crew closes hatches. The engine growls. The tank positions itself. All eyes move to the hedgerow, untouched for centuries, undefeated for 6 weeks. Cullen stands beside Bradley, silent. He knows what this moment means. The order is given. The tank accelerates. Steel meets earth, and history begins to crack. To understand the importance of what happened near Saint-Lô, we must return to the problem that brought the Allied army to a standstill. After D-Day, American forces pushed inland, only 8 miles in over a month. It was not a lack of courage nor a lack of armor. It was the bocage, a landscape unlike anything the U.S. Army had trained for. These hedgerows were not ordinary vegetation. They were medieval earthworks, walls built by French farmers over centuries. Fieldstones stacked and buried, soil piled over time, roots twisting deep into the ground, trees growing atop the mounds. The result, a 4-foot-thick barrier, 12 feet high, stretching across Normandy in thousands of irregular fields. A natural fortress, a sniper's paradise, and a tank commander's nightmare. Sherman tanks could crush fences, brush, or even small walls. But when they struck the bocage, they climbed upward, lifting their hulls and exposing the weakest part of their armor, the 1-inch belly plate. German infantry, hiding just feet away, waited with Panzerfausts and anti-tank guns aimed at exactly that spot. One hit, hull breached, fuel ignites. A tank becomes an inferno before the crew can escape. For 6 weeks, this scenario repeated across the Norman countryside. Units from the 2nd Armored Division and 1st Army probed field after field. Roads were narrow death traps. Explosives barely dented the earthen walls and only drew German artillery. Engineers cleared a path, and by sunset, enemy forces had reoccupied it. Progress measured not in miles, but in yards. Victory depended not on firepower, but on finding a way through ancient dirt and roots. Behind the Allied front line, pressure mounted. Operation Cobra, the planned breakout, demanded speed and shock. Tanks were supposed to lead that charge, not sit idle behind hedges. Yet by early July, one truth had become clear. If the United States could not overcome the bocage, the war in Western Europe would slow to a grind. Every day lost allowed German reinforcements to gather deeper inland. A mechanical solution did not exist. Dozer tanks were too few and obvious targets. Explosives failed. Brute force only killed crews faster. The greatest military machine ever assembled had met an obstacle built by farmers centuries earlier. In this environment, Innovation would not come from a strategy meeting, but from a welding torch and an enlisted man who refused to accept defeat. By early July 1944, the situation in Normandy had reached a critical point. After breaking free from the beaches on June 6th, American forces had managed to push only 8 miles inland. The cost was brutal. Over 400 Sherman tanks lost in 6 weeks of grinding hedgerow fighting, many burning before their crews could escape. The bocage was not just slowing the advance, it was threatening the momentum of the entire campaign. Every field was a fortress, every road a choke point, every hedgerow a potential death trap. Commanders knew that if this continued, the Allied invasion could bog down before it ever truly began. The stakes sharpened as planners prepared for Operation Cobra, the major breakout offensive designed to shatter German lines and open the road into France. Cobra was the strategic hinge of the Western Front. It required speed, surprise, and armored mobility, the one thing Normandy's terrain refused to allow. Calculations were stark. At the current rate of advance, it would take 6 months to travel 20 more miles. And behind that estimate lay a frightening truth. Every day wasted gave the Germans more time to reinforce and fortify the interior of France. Time was an enemy, just as real as the panzer divisions beyond the hedgerows. The U.S. First Army faced a dilemma unprecedented in modern mechanized warfare. Tanks could not maneuver, infantry could not advance, and artillery could not uproot entrenched defenders without risking friendly fire in the maze-like fields. The United States possessed unmatched industrial strength, but no machine built in Detroit or Pittsburgh had been designed for this ancient landscape. If Cobra failed to launch on schedule, and if American armor could not break free into open country, the enormous sacrifice that followed D-Day risked turning into a drawn-out war of attrition in the hedgerows of Normandy. The pressure on field units grew, and so did the urgency for a solution nobody had yet found, until one sergeant looked at German scrap steel and saw an answer where others saw debris. The U.S. Army did not enter Normandy blind to engineering challenges. In the first weeks after the landings, every conventional and improvised method was tested in an effort to break the hedgerow problem. None worked. Combat engineers tried placing explosives at the base of hedgerows, hoping to blast openings wide enough for tanks to pass. But the earth walls, hardened by centuries of roots and stone, absorbed the force. The charges left little more than scorch marks and craters, while the sound immediately drew German artillery fire. What was meant to clear obstacles instead exposed American troops and guns to even more danger. Commanders then turned to heavy equipment. Bulldozer-equipped Shermans were deployed to push through the hedgerows by brute force, but each battalion had only 4 dozer tanks, and the moment a dozer blade lifted a hedge, it became the primary target on the battlefield. German anti-tank gunners quickly learned to wait for the blade, and one hit disabled not only the tank, but the only breaching tool available to its unit. Meanwhile, crews everywhere began welding spare track links and armor plates to their hulls, hoping to protect against the inevitable upward shot from a Panzerfaust hidden at arm's length. The extra steel helped against small arms fire, nothing more. It did not stop shaped charge warheads, nor did it solve the fatal exposure of a climbing tank. Other crews resorted to sheer speed and force. Some attempted full throttle ramming, hoping momentum alone could punch through the hedges. The results were disastrous. Shermans buried themselves nose first into walls of earth and roots, immobilizing the vehicle and leaving their vulnerable underside exposed. Crews who survived the collision were often killed seconds later by anti-tank weapons that needed only a single opening. In battle reports across the First Army sector, one phrase appeared again and again: no effective method available. The U.S. Army, a mechanized force built to maneuver, found itself fighting a medieval landscape designed to stop movement. Every solution had been tested. Everyone had failed. Units fought, improvised, bled, and died. Progress slowed to yards per day. The bocage problem was not a tactical inconvenience, it was a strategic crisis. And as casualties mounted and Operation Cobra approached, the truth became undeniable. Traditional thinking would not win this fight. Only innovation would. Amid the stalled advance and mounting losses, the solution did not come from a laboratory or a headquarters briefing. It came from a field workshop, a welding torch, and a sergeant who refused to accept that American armor could be beaten by dirt. Sergeant Curtis Cullen, serving with the 102nd Cavalry Reconnaissance Squadron of the 2nd Armored Division, spent weeks operating in the hedgerows. He saw firsthand how tanks died in the bocage, not because they lacked firepower, but because they could not fight the terrain. Where others saw impenetrable earthworks, Cullen saw a mechanical problem waiting for a practical answer. The raw material for his idea littered the beaches the Army had just fought across. The Germans had planted thousands of Czech hedgehogs on the Normandy shoreline. Heavy three-beam steel obstacles welded into a jack shape, designed to rip open landing craft and drown Allied soldiers before they reached sand. After securing the beaches, American engineers cut these obstacles apart using torches and piled the pieces inland. They were considered battlefield trash. Heavy, awkward steel with no planned purpose. Cullen saw something else: strength, angle, mass, and the possibility of turning German defenses into American tools. Over 3 days, he cut and reshaped the hedgehog beams into 4 thick steel prongs, each 2 inches thick and angled forward at 35 degrees. Instead of forcing a tank to climb the hedgerow, these prongs were designed to bite into its base, tear through roots and earth, and allow the tank to drive straight through, keeping its vulnerable belly armor low and shielded. His first tests were not on a Sherman, but on a light tank, weighing about 15 tons. He tested the assembly 7 times, 7 successful breaches. The device did not bend, did not break, and did not fail. It punched cleanly through hedgerows that had stopped the U.S. First Army for more than a month. The idea was simple, improvised, and created in the field, but it solved the one problem that doctrine, engineering, and brute force could not. Cullen had built a weapon out of scrap, a tool forged from German steel, crafted under fire, born from necessity, and shaped by experience. What remained was the most difficult step: proving to the Army that this field-built invention could change a campaign. That opportunity was coming, and it would unfold in front of the highest-ranking commander on the ground in Normandy. Word of Cullen's improvised hedgerow-cutting device spread quickly through nearby units. His light tank tests proved promising, but they weren't enough. A 15-ton light tank could cut through bocage, but Normandy would be won or lost by 33-ton Sherman tanks. Twice the weight, twice the stress. If the prongs tore off under impact, the tank could dig into the earth, flip forward, or stall in front of enemy guns. A battlefield idea now needed battlefield proof, at full combat weight. Enter Major Sidney Bingham of the 2nd Armored Division. After seeing Cullen's tests on the lighter vehicle, Bingham ordered the next step: weld the prongs onto a Sherman. It was a risky call, but the situation demanded boldness. Lieutenant Charles Green of the 747th Tank Battalion volunteered his tank and crewmen, who already understood the cost of hedgerow fighting and were willing to gamble on a new idea to survive it. Cullen and mechanics welded the 4-prong assembly, roughly 320 pounds of hardened German steel, directly to the Sherman's bow plate. There were no engineering manuals, no official approval, no prototype shop from Detroit, only torches, sweat, and the hope that the tank's armor mountings could withstand the shock. On July 11th, they ran the first full-weight trial. The Sherman roared forward, struck the bocage, and punched clean through. No damage, no structural failure. 4 more tests followed, 4 more breaches. The device was held every time. By now, the rumor had reached the top. Tanks had found a way through the hedgerows, and the solution had come not from headquarters, but from a sergeant with welding rods and captured steel. 2 days later, General Omar Bradley ordered a personal demonstration outside St. Lo. It would not be a quiet trial. It would be a moment of judgment. One invention against an entire theater of war. If the device worked under the eyes of the Army's senior commander, it could change the course of the campaign. If it failed, the U.S. First Army would return to losing tanks, losing men, and losing time in the ancient Norman fields. Cullen's invention had passed every test so far, but now the fate of the idea and perhaps the breakout from Normandy, stood before the highest authority on the battlefield, July 13, 1944, near St. Lo. The battlefield was quiet except for the distant thump of artillery. The hedgerows stood untouched, thick and ancient, the same barriers that had stopped an army for 6 weeks. On that ground, under the eyes of senior commanders, the Sherman, equipped with Cullen's device, prepared for the most consequential test of the Normandy campaign. General Omar Bradley, commander of the U.S. First Army, had come to see the demonstration himself. This was no routine evaluation. Bradley understood the stakes, the pace of the invasion, the fate of Operation Cobra, and the lives of thousands of tank crews depended on a solution that did not yet officially exist. Standing nearby, Sergeant Curtis Cullen waited, not as an engineer or an officer, but as a soldier whose field-born idea now held the weight of an army. Lieutenant Charles Green and his Sherman crew sealed their hatches. The newly welded 320-pound steel prongs, cut from German beach obstacles and forged into crude metal teeth, jutted from the tank's bow. The vehicle idled, engine rumbling against a barrier older than the United States itself. Soldiers gathered to watch. If the prongs failed, the Sherman could bury itself, break its suspension, or worse, become a sitting target. Bradley pointed to a hedgerow nearly 12 feet high, packed with roots and soil thicker than any wall in a European town. For 42 days, tanks had died trying to climb barriers like it. This one would prove whether Cullen's invention lived or died. The order came. The Sherman surged forward, gathering speed across open ground. Dirt kicked beneath its tracks. In seconds, steel struck earth, not climbing, not lifting, biting. The prongs dug into the base of the hedgerow, cutting into centuries-hard soil and buried stone. The tank's bow dipped, pressed, and pushed. Roots snapped, earth split. And in a single motion, the Sherman punched through the ancient barrier, bursting out the far side in roughly 14 seconds. Silence followed. Bradley lowered his binoculars. Officers examined the breach. Torn earth, shredded roots, tank tracks clean through. No climb, no belly exposure, no vulnerability. The problem that had halted First Army had just been defeated by 4 pieces of steel scavenged from the enemy's beach defenses. Bradley turned to his staff. The command was simple and immediate. Build them, all of them. What began as a field modification has now become a directive. Welders would work without pause. German steel would be cut, filed, and repurposed. Every tank possible, Sherman, a light tank, and tank destroyer, would receive the device. There were 12 days until Operation Cobra. The Army would use every one of them. The hedgerows were no longer impenetrable. The breakout had found its key. The demonstration at St. Lo changed everything. Within hours, General Omar Bradley issued one of the most urgent engineering orders of the campaign. The U.S. First Army would equip every possible armored vehicle with Cullen's hedgerow-cutting device. The directive fell to the 52nd Ordnance Group, and the scale bordered on impossible. They had just 12 days until Operation Cobra, the breakout that would decide the fate of Normandy. In that time, they were expected to modify 3,000 armored vehicles. By the Army's own estimates, that meant outfitting 1 tank every 6 minutes, around the clock, without pause. Raw materials existed, but not without effort. The steel for these cutters came from the enemy themselves. American engineers began seizing, cutting, and hauling every Czech hedgehog beach obstacle they could find, from the landing zones to the outskirts of Cherbourg. Welders, torch teams, and mechanics swarmed makeshift workshops in open fields. The device had been invented in combat. Now, it had to be industrialized in combat. Yet, reality struck almost immediately. The first day of production yielded only 8 completed tanks. At that pace, the Army would finish sometime in October, long after the breakout window had closed. Torches overheated against hardened German steel. Welders fought equipment breakdowns and heat fatigue. The process was slow, laborious, and unforgiving. The bocage problem was no longer only on the front line. It had moved to the welding pits and supply depots behind it. Still, the urgency never faltered. The fate of the Normandy advance now depended as much on cutting torches as on tank cannons. The question was no longer whether Cullen's invention worked, but whether the Army could build enough of them in time to change the war. The first days of mass production made one truth painfully clear. Having the solution was not enough. The U.S. First Army now had to manufacture a battlefield invention at an industrial scale, inside an active war zone, under an immovable deadline. And nothing about it was simple. The German steel taken from Czech hedgehogs turned out to be far tougher than standard American plate. Cutting torches overheated in minutes. Welders rotated equipment just to keep their tools from burning out. The first day produced 8 devices. The second day, only slightly more. At that rate, fewer than 100 tanks would be ready by Operation Cobra when thousands were required. Cullen refused to let the idea die in the workshop. He spent July 15th moving through the field production lines, identifying bottlenecks and adjusting the welding process. He reorganized crews into rotation shifts, one team cutting steel while another cooled torches and swapped tips. The changes paid off. Production rose, 22 cutters on July 15th, 38 the next day, but it was still nowhere near enough. The technical challenges continued to surface. The 320-pound prong assembly, when mounted directly to the Sherman's bow, shifted its center of gravity forward by nearly 6 inches. After multiple test impacts, mechanics found signs of stress fractures in the tank's front suspension springs. If left unresolved, entire units could find themselves immobilized mid-assault. Cullen adapted again. He redesigned the mounting approach, adding reinforcement brackets that distributed weight across the hull instead of stressing the suspension alone. The revision added 30 minutes to each installation, a painful delay when time was the most precious asset, but it eliminated catastrophic failures in testing. Meanwhile, the manpower race intensified. Welders arrived from maintenance battalions across Normandy. Tank recovery teams contributed their equipment. Captain James Docherty and the 52nd Ordnance Group built what was, in effect, a mobile factory spread across fields near Colombières. The workshop never slept. Floodlights burned through the night. Sparks showered off steel until dawn. By July 19th, output had risen to 64 cutters per day. A breakthrough, but not yet victory. Operation Cobra was just 6 days away, and the arithmetic remained brutal. Thousands of tanks were needed, hundreds completed, only days left. The war in Normandy had already forced American crews to improvise in combat. Now it demanded that an entire support network, welders, engineers, drivers, mechanics, wage their own battle behind the lines. And like the soldiers at the front, they were running out of time. By late July, the race between invention and time tightened to a razor's edge. Operation Cobra was coming, July 25th, an immovable date. Tanks needed cutters or they would die in the hedgerows. Pressure inside the improvised welding yards at Colombières rose with every sunrise. The progress was real, but the scale remained daunting. By July 19th, roughly 400 tanks had been outfitted. Over 2,600 still required modification. Welders worked under floodlights, breathing in smoke and flux as sparks rained across open fields. Exhaustion set in. Nobody slept more than a few hours. But steel alone was not enough. Now, the Army faced a new crisis. The steel was running out. The teams had already stripped the beaches and road exits of Czech hedgehogs. Every accessible German obstacle between the landing areas and Cherbourg had been cut down and carted away. Without a new supply, the installation effort would stall just as momentum reached its peak. Then, another frontier of improvisation opened. Engineers identified additional hedgehog stockpiles near Utah Beach, still intact but far from the welding sites. Convoys diverted precious fuel and transport capacity to haul the steel inland. When that too fell short, units turned to whatever they could salvage. Railroad track sections, softer than German steel, heavier and harder to shape, were cut and welded into substitute prongs. They were crude but functional. The tankers called them Green Dozers, after Lieutenant Charles Green, whose battalion pioneered the design. Work intensified. More welders arrived. 15 new welding stations came online on July 21st. Output surged, 112 tanks per day at the peak. Field workshops became something extraordinary. a wartime assembly line operating in open grass, soaked in sweat, lit by generator lamps, fueled by sheer necessity. By July 22nd, the tally climbed to 200 modified vehicles. By July 23rd, nearly 1,800. The steel shortage forced a hybrid approach, Cullen's hedgehog cutters for some units, railroad prongs for others. The final projection came in. Approximately 2,300 Rhino tanks would be ready. Well short of the original target, but above Bradley's minimum operational requirement. The last days before Cobra saw columns of Shermans rolling forward towards staging areas, every one of them now sporting heavy steel tusks on its bow. They looked strange, almost primitive, like armored beasts fitted for ramming. But those crude teeth represented a hard-won miracle, an improvised device built in fields, not factories, ready just in time. At dawn on July 25th, the cutters would face their true test. The First Army would either burst out of Normandy or remain trapped behind centuries-old earthen walls. The welding torches finally cooled. The tanks rolled to the line of departure, and the hedgerows, which had stopped the might of the United States Army for 6 long weeks, were about to meet steel with purpose. July 25, 1944. Dawn broke over Normandy beneath the distant roar of engines. The ground near St. Lo trembled as the sky filled with Allied aircraft, bombers, fighters, and attack planes massing for the most concentrated airstrike the U.S. First Army had yet unleashed. In a 90-minute bombardment, nearly 3,000 aircraft dropped 4,000 tons of explosives across German positions. The earth shook. Entire hedgerow lines vanished under dust clouds. Then, suddenly, a deep, unnatural silence settled over the battlefield. At 7:45 a.m., the first Rhino-equipped Shermans moved. The breakthrough attempt was no longer theory, no longer welding sparks in a rear area. It was happening in real combat. 2nd Armored Division led the assault, followed closely by 3rd Armored Division, with 1st Infantry Division in support. Tanks rolled forward, tusked steel gleaming under the morning sun, the improvised cutters jutting out like the horns of prehistoric beasts. Within minutes, the radios crackled to life. Company B of the 2nd Armored reached its first hedgerow barrier. Gunfire echoed from deeper fields as German defenders waited to strike at climbing tanks, as they always had. But this time, the Shermans did not climb. They accelerated. The prongs hit the base of the hedge, dug, and tore. In 16 seconds, the first American tank punched through a wall that had previously required hours or sacrifices to overcome. No belly lift, no pause, no catastrophic explosion from a hidden Panzerfaust. More reports followed in rapid succession. Company C breached 3 hedgerows in 20 minutes. Company A cut through 5 in a single advance without delay. German defenders, positioned to fire upward at exposed undersides, found their angles useless. Their carefully prepared kill zones collapsed the moment the Americans refused to climb the walls. The effect spread across the sector. Where Allied tanks had once advanced at a crawl, pinned field by field, the 2nd Armored Division advanced roughly 2 miles by mid-morning, a distance that had previously taken 3 days of bloody fighting. And radio messages from the 3rd Armored Division mirrored the success. The hedgerows, the obstacle that had halted the First Army, were no longer impenetrable defenses. They were now simply terrain, and the American armor moved through them with unprecedented speed. For 6 weeks, the bocage had denied men and machines, swallowed lives, and dictated tactics. This morning, for the first time, it yielded. The breakout had begun, steel prongs leading the way. The Rhino tanks transformed the battlefield, but even innovation carries a price. As Operation Cobra surged forward, success came fast. Yet flaws emerged just as quickly. Not every cutter survived its first combat day. The hedgerows of Normandy were ancient, unpredictable, and unforgiving. Most yielded. A few fought back. Late morning reports detailed the first failures. A Sherman from the 751st Tank Battalion, striking a hedgerow reinforced with buried stone, had its prongs bent backward on impact. The tank could neither reverse nor push forward. German machine gun fire swept the field as the crew bailed out. 2 men were killed in the attempt. Minutes later, a light tank struck a concealed iron fence post embedded inside the hedge line. The impact ripped the entire device from the hull, taking part of the bow plate with it. The tank remained mobile, but could breach no more. At 11:20 a.m., a third report arrived. A tank destroyer equipped with railroad steel prongs hit a hedge at 30 miles per hour, too fast for the improvised brackets to absorb the shock. The mounts buckled and the prongs twisted sideways, jamming the right track. The crew was forced to abandon the vehicle under fire. These incidents, isolated but painful, revealed the limits of field-manufactured steel and combat stress improvisation. Across the lines, analysts began to see a pattern. Roughly 4% of cutters failed under combat loads, around 92 tanks out of the 2,300 equipped, each one a steel-armored coffin when immobilized in open fields. Cullen monitored these reports. Every success mattered. Every failure weighed heavier. He understood what a trapped Sherman meant in the bocage. He had seen it before this invention existed, and he knew some crews now paid the price for design constraints he had never had time to refine. Yet, even as individual devices failed, the system held. For every broken prong, dozens carved fresh lanes through terrain once considered impregnable. Failure was tragic, but limited. Innovation in war is rarely perfect. Here it only needed to be decisive, and it was. Dozens of tanks lost had been replaced by hundreds saved, and stalled advances had become sweeping movements. By 1:30 p.m., radios brought a message that eclipsed all earlier doubts. A battalion from 3rd Armored Division had reached the Marigny-Saint-Gilles road, 4 miles from their start point. The advance had taken 6 hours, not 2 weeks. The hedgerows, once the graveyard of American armor, were becoming corridors of rapid attack. The Rhino cutters were not flawless, but they were enough to move, enough to break the stalemate, enough to trade uncertainty for momentum, and momentum for victory. As the afternoon of July 25th unfolded, the battlefield transformed from a grinding stalemate to an accelerating breakthrough. Reports streamed into 1st Army headquarters. Armored spearheads were no longer crawling field to field. They were racing. By 3:00 p.m., advance units had pushed 5 miles inland, forcing German formations to abandon prepared defenses and scramble backward. The hedgerows that once acted like fortress walls were suddenly nothing more than shredded dirt and roots behind American tanks. German defensive doctrine imploded in real time. For 6 brutal weeks, Panzerfaust teams and anti-tank guns had waited for Shermans to expose their thin underbellies, a predictable moment that had become a death sentence for U.S. crews. But now the Americans were not climbing over hedgerows at all. They punched through them at ground level, the exact place German gunners couldn't target. Camouflaged ambushes lost their angles. Kill zones vanished. Entire German squads watched, stunned, as tanks pierced barriers they believed impassable. Across the front, communications from German commanders echoed shock and disbelief. Positions considered anchor points crumbled because they simply could not hold long enough to re-establish fire lines. Tanks led the infantry instead of waiting behind them. Routes that once took days to negotiate now open in minutes. Normandy's ancient earthworks, the walls that countless armies across centuries had respected, suddenly held no tactical meaning. And still, the system was not perfect. Cullen knew the math. Roughly 4% of cutters failed, meaning about 92 tanks would be stranded and some crews would be lost. Yet as the sun dipped over Normandy, one truth outweighed every flaw. For the first time since D-Day, American armor controlled the pace of battle. By evening, radio traffic from multiple divisions confirmed the magnitude of the shift. Units reported advances measured not in hedgerows cleared, but miles taken. German forces began withdrawing toward Coutances and the Say River line, unable to slow the American momentum. The bocage, the very terrain that had nearly strangled the invasion, now served as a funnel accelerating German collapse. Curtis Cullen watched it unfold from a forward observation point, exhausted, burned from welding torches and operating on fragments of sleep. He had spent weeks fighting soil, steel, and time itself. And now he listened as entire armored brigades cut deep into France using the crude iron tusks he had dreamed up on a Normandy beach. The bocage, obstacle, graveyard, nightmare was breaking, and the breakout from Normandy had truly begun. By July 26th, the shockwave of the breakout rolled across Normandy. German units pulled back in disorder, command posts abandoned, and artillery positions overrun before they could relocate. Allied intelligence reports noted a shift. The enemy was no longer maneuvering. They were retreating. And at the spearhead of that advance were the Rhino Shermans, forcing momentum into terrain where momentum had once been impossible. Production did not stop simply because the first wave succeeded. In the fields around Colombières, welders returned to their stations, continuing the work that battlefield victory had now justified. Additional steel arrived from secondary beach defenses. Railroad tracks were cut into angular tusks and fitted where German iron had run out. Within days, the tally of modified vehicles climbed from roughly 2,300 to nearly 2,850. The Army had forged a fleet of hybrid tanks, part American, part scrap from Hitler's Atlantic Wall. And the tactical impact spread far beyond the breakout line. 2nd Armored Division burst south toward Coutances. 3rd Armored Division pushed deeper east. 4th Armored Division received cutters on July 30th and drove toward Brittany, tearing through the last pockets of hedgerows that dared resist. As the U.S. forces poured into open country, tank losses dropped by over 1/3 compared to the brutal weeks of June and early July. Hundreds of crews survived because they no longer had to fight the earth itself. The Germans had relied on bocage to equalize the fight, but now, with each hedgerow shattered by steel prongs, their defensive map disintegrated. Captured officers later admitted that morale collapsed the moment they realized American tanks could break hedges at will. Some described watching Rhino Shermans smash through walls they believed unbreakable, and simply fleeing. When Paris was liberated in late August, a few Rhino-equipped tanks rolled proudly through the city, their prongs still mounted. Curious French civilians cheered without knowing what the strange iron teeth meant. But the tank crews knew. They had survived because of them. Yet even as acclaim grew, the bocage cutters were slowly removed. Beyond Normandy, the terrain widened. Open fields replaced earth fortress lanes, and speed mattered more than brute-forcing soil. Many units unbolted their devices. Some kept them loaded on support trucks just in case. The cutters had served their purpose, and served it brutally well. Curtis Cullen, meanwhile, did not parade in Paris. He was reassigned to training duties, teaching replacement crews how to breach hedgerows, even as the war moved past them. Weeks later, he returned to his cavalry unit and resumed life as a frontline sergeant. No spotlight, no special posting, just another soldier marching east as France opened before the Allies. The Rhino cutters faded from view. The bocage receded behind the front lines. And the man whose idea freed First Army to advance across France stepped quietly back into the ranks, knowing the work was done, and thousands of men were alive because of it. When the guns finally fell silent in Europe, the Rhino tanks were long gone. Their steel prongs cut off, scrapped, or sitting forgotten in fields where welders once worked through moonlit nights. The breakout from Normandy had become history, celebrated in newsreels and print. Yet the story behind it, the field ingenuity of one sergeant, quietly faded into the background. Curtis Cullen returned home in 1945 not to parades or public recognition, but to ordinary life. He married, found steady work in New York, and built a future far removed from the hedgerows of Normandy. His invention had broken a battlefield deadlock, saved thousands of American tankers, and altered the course of the campaign. Yet outside military circles, few knew his name. That would change slowly. General Omar Bradley's memoirs, published in 1951, singled out Cullen's innovation as the turning point in the bocage campaign. Military historians took notice. Training manuals referenced the Cullen device, and armored schools studied it as a model of combat improvisation. The lesson was powerful. Great ideas on the battlefield don't always come from headquarters. Sometimes they come from soldiers with dirt under their nails and weld burns on their hands. Still, Cullen never sought the spotlight. He never toured, lectured, or demanded recognition. He died in 1963 at the age of 48, believing his contribution might always remain a footnote. But history had other plans. In 1964, on the 20th anniversary of D-Day, former Supreme Allied Commander Dwight D. Eisenhower told the story on national television. Standing in the bocage itself, he described how a sergeant from New Jersey solved a problem that had baffled generals. Cullen's name finally reached millions. Today, visitors at museums in Fort Knox, New Orleans, and Normandy stand before Shermans fitted with his crude steel tusks. They see the prongs, simple, ugly, improvised, and learn how they unlocked roads to Paris, to victory, and to home. Modern soldiers study Cullen's work not as a relic, but as a doctrine. Use what you have, solve the problem in front of you, and trust initiative, even when orders haven't caught up yet. There is no towering monument to Curtis Cullen. His grave in New Jersey is humble, his service record brief. Yet his legacy lives in every tank crew that survived Normandy, in every armored advance that followed, and in every soldier who has ever welded scrap into survival. His invention didn't just break hedgerows. It broke the idea that only generals shape history. Sometimes wars turn on grand strategy. Sometimes they turn on a quiet man with a torch, a problem, and a vision. And because of one sergeant's welding sparks in a muddy field, thousands of families welcomed their sons home. Men who lived to tell their own stories, because Curtis "Grub" Cullen changed the battlefield with iron, grit, and a moment of genius.